Namaskaram to everyone, and welcome to Epic Minds, where we explore the unknown, the unseen, and the unexplainable. The universe runs on atoms. They make up everything from the stars in the sky to the air we breathe. For billions of years, atoms quietly powered the cosmos, but in the 20th century, humanity discovered how to unleash their hidden energy in a single instant. That discovery gave birth to the nuclear bomb, the deadliest weapon ever created. In 1938, German scientists discovered nuclear fission. When a neutron strikes the nucleus of uranium 235, it splits into smaller atoms, releasing enormous energy. Even more important, the split releases extra neutrons, which can strike other uranium atoms, creating a chain reaction. One atom splits, then two, then four, then eight, a runaway cascade. In less than a millionth of a second, this reaction can release energy equal to thousands of tons of TNT. Albert Einstein's equation E is equals to mc square had predicted this. Matter could be transformed into pure energy. The question was no longer if it could be done, but how it can be controlled or weaponized. The energy from splitting just 1 kilogram of uranium is equal to 20,000 tons of TNT. As World War II raged, fears grew that the Nazi Germany might build such a weapon first. In 1939, physicists Leo Szilard and Albert Einstein warned President Roosevelt of the danger. The result was the Manhattan Project, the most secret, most ambitious scientific program in history. Over 130,000 scientists and workers across the US were tasked with one mission: harnessing the power of the atom before the enemy did. The challenge were enormous. Natural uranium contained less than 1% uranium-235, the isotope needed for fission. Also had to invent new technologies to separate it. At the same time, reactors were built to create plutonium-239, another fissile material. So, two bomb designs emerged. Little Boy, a gun-type bomb using uranium-235, and Fat Man, an implosion bomb using plutonium-239, compressed by conventional explosives into a critical mass. In both, the goal was the same: drive the material into a supercritical state so that the chain reaction would go uncontrollably, releasing an explosion in millionths of a second. On July 16, 1945, at a remote desert site called Trinity, the first nuclear bomb was detonated. The desert lit brighter than the sun. A fireball hotter than the surface of the sun expanded outward, vaporizing everything nearby. A mushroom cloud soared 12 kilometers high. One scientist recalled a verse from the Hindu scripture: "Now I am become death, the destroyer of worlds." The atomic age had begun. On August 6, 1945, the uranium bomb Little Boy fell on Hiroshima in an instant, killing 70,000 people. 3 days later, Fat Man destroyed Nagasaki, killing 40,000 people more. The temperature at ground zero reached over 4,000 degrees Celsius, enough to melt steel. Buildings vanished. People were vaporized, leaving only their shadows burned to the walls. The war ended, but the world would never be the same. First-generation nuclear bombs relied on fission alone, but soon scientists realized that they could go further. By using a fission bomb to compress and heat hydrogen isotopes, they could trigger fusion, the same reaction that powers the sun. These became thermonuclear or hydrogen bombs, hundreds of times more powerful than the Hiroshima bomb. A single hydrogen bomb could level an entire metropolis. Today, the most powerful bomb ever tested, the Soviet Union's Tsar Bomba, released energy equal to 50 million tons of TNT. After 1945, the world entered a new era. The US and Soviet Union built thousands of warheads, pointing them at each other in a tense standoff called the Cold War. The strategy was mutually assured destruction. If one side launched an attack, the other would retaliate, ensuring the annihilation for both. For decades, humanity lived under the shadow of a button that could end civilization. The danger of nuclear bombs is not just a blast, it's in what comes after. When a nuclear weapon denotes over a city, the firestorm ignites everything: buildings, vehicles, forests. These fires produce massive amounts of soot, tiny carbon particles like the smoke from a candle, but billions of times more. Normally, this smoke settles down, but nuclear firestorms are so intense that the soot rises to the stratosphere, far above where rain can wash it away. Once there, it spreads across the globe, forming a black veil that blocks sunlight. Days become dim, temperatures plummet, crops fail. This is called a nuclear winter. Even a war with just 100 Hiroshima-sized bombs could inject enough soot to lower global temperature by several degrees for years. Billions could starve. In simulations, 5 to 10 million tons of soot from city fires could reduce global food production by up to 40% in the first year. Radiation poisoning, cancers, genetic damage, contaminated water. These are invisible scars of nuclear war. Survivors of Hiroshima and Nagasaki, called hibakusha, carried lifelong diseases and trauma. But in a full-scale nuclear exchange would be even worse. Not just the loss of cities, but the collapse of the global civilization itself. Decades after Hiroshima and Nagasaki, nuclear weapons have not disappeared. Instead, they have multiplied. Today, 9 nations possess nuclear weapons, from superpowers of the United States and Russia to newer members like North Korea. Global stockpiles once reached 70,000 warheads at the height of the Cold War. Though treaties reduced that number, more than 1,200 nuclear weapons remain. Many are ready to launch within minutes, and the threats are not theoretical. Leaders have openly spoke of using nuclear weapons in conflicts. North Korea usually displays them in military parades. Tensions between India and Pakistan, 2 nuclear-armed neighbors, have brought the world close to the brink. And during Russia's invasion of Ukraine, nuclear threats once again echoed across the Atlantis. For the first time since the Cold War, the doomsday clock, a symbolic measure of how close humanity is to a catastrophe, stands at 90 seconds to midnight, the closest it has ever been. The nuclear threat is not history, it is now. The atom gave us the power of the stars, but with that power came responsibility. The story of nuclear bombs is not just about destruction, it is about choice. The choice between survival and annihilation, between life and death. And in the end, the greatest weapon humanity holds is wisdom.